Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all in today's session. Well, to access the notebook for today's session, uh, you can access course page on my personal website arifbut.me. You can click the appropriate link under the lecture resource column to view it in NB Viewer and run it online in Binder. The other way is to download the notebook from the course GitHub account, Arif PUC80, and all the notebooks for this course are housed in this public data science repository. Well, this is the Jupyter Notebook dashboard running at port 8888, and here is the notebook for lecture number 8 of the third module, Python Programming for Data Scientist, for the course titled Tools and Techniques for Data Science. Well, my dear students, today is the last session on NumPy arrays, and we will understand performing I/O operations with NumPy arrays today. Well, my dear friends, we have already seen the Python's built-in open function to open text as well as binary files in our file handling session of module 2. In that session, we use the read line and read lines methods to read the contents of text files. As well as we use the write and close methods to write and close the files respectively. Today we are going to see as how we can read numeric data stored in text files or these CSV files and load it into NumPy arrays for processing or performing some basic analytics on that data. And here is the agenda. In bonus one, we will download some climate related data stored in CSV format, load it in NumPy array for processing. And in bonus 2, we will repeat the same for an image file. So let's start playing. Okay, so first of all, reading data from files. My dear students, load txt is the NumPy method that we are going to use to load data from text file, numeric data. We can also use generate from text, gen from txt. This is more powerful than this load text, as it provides the facility to handle the null values as well, or missing data as well. So let's straight away jump to an example. So this is our file data0.txt. Let me show you the contents of this file. It is just a numeric data, space separated data residing in this text file. We are using this cat command of the operating system to view this file. And if I want to read it from inside Python, I can use the NumPy generate from text method. The only required argument is the path of this file, and this returns this data inside a NumPy array. And of course, you can just watch it. Let me import the NumPy module and run it again. Great. So we have successfully read this file, read the data in this file, numeric data, and loaded that into this NumPy array. One more important point to note that in this file over here, this data is in integer format, while the default behavior of generate from text method is that it typecasts that data to a floating point value. That's why you are seeing this 45 point and 91 point and so on. Okay, so let's see another example. This is another file data1.txt, and this time this file contains numeric data separated by spaces, and this time it is in multiple lines. One point to keep in mind is that the count of numbers on each line must be same. Only then we will be able to read it in using this method, generate from text. So it's once again very simple. We have just successfully read this data. And in case if you are sure that this data is integer data and you want to load it in integers, you can mention the d type argument to generate from text. So over here I have mentioned the data type as np.uint8 unsigned 8-bit data. So this will of course save space whenever you are reading hundreds and thousands of numeric data inside this array in your memory. While you all know that in case of floats it takes 8 bytes in Python. Great. So let's see something else as well. Okay, so this is another file, ice cream sales underscore simple.csv. So this is a file which contains two values on each line, comma separated. So by default, this generate from text method assumes that the data is space separated. So over here you need to pass the delimiter, whatever is the delimiter. In this case it is comma, so I have mentioned a comma over here. And so this data is again read inside this NumPy array. Great. And of course you can call the shape method of NumPy array, which tells you that there are 12 rows and 2 columns. Each row contains this data, and I think in the first column we have the temperature, and in the second column we have the sale of the ice cream. Great. So more is the temperature, more is the sale. Makes sense. Let's see this other example. Over here, this is again the same file, but this time it has a header. The header tells you that the first column is temperature and the second column is sales. Now, if you use this generate from text method to read this file, you need to pass it another argument, that is skip header. So while reading such a file, since we do not need this string inside the NumPy array, so I will pass this argument skip header. So in this case, I have passed the skip header is equal to 1 to skip this first line. So it will not read this line and read the data as such. 12 rows, 2 columns. Great. Okay, so let's see this example as well. My dear students, this time this ice cream sales underscore with comments.csv. This is a file which other than the data has certain comments. And remember this generate from txt method by default assume that the comments start from this hash. So even if you don't pass this argument, this file will be successfully read. However, if you are working in a file in which the comment is preceded with some other character, you need to mention that over here. Great. So these are some of the important arguments that I thought necessary that you should know while reading data from text files. They are the data type, the delimiter, the comments, and the headers. For more details, you can just get the help. So this is the help page of this file. You can just scroll it, see different arguments that you can use whenever you have some problem to read the help page of generate from text. Okay, so let's move on to the next task, that is writing the data back into the file. So we can use many methods, but I will be using save txt for this task. The save txt is passed a lot of arguments. The first is the file name in which you want to save. Then is the array which you want to save in that file. The data is residing inside the memory inside this array. Then we have the format. You can mention the format, whatever floating point format you want to specify while saving it inside this file. The delimiter, the default is space. You can mention comma over here. The new line character, header and footer are by default null or no string. You can mention the header and footer if you want to, and of course you can mention the comment character as well. Great. You can use the save z and save z underscore compressed as well if you want to archive and zip the array data inside these files. Do see the help pages for this. Okay, so let's suppose that we have this array having a 3 by 3 array having floats. So I'm just using the save txt method to save the data inside this file arr1 inside inside this arr1 numpy array to this my arr.txt file. So this has successfully written that. Let me use the cat command to view that. You can see that, and of course I can use generate from text to read that file again inside this arr2. I hope this is making sense. This is just piece of cake. Okay, so over here we have used no argument for the delimiter, so it has used spaces. If you want to have the delimiter as comma, so you can use comma over here. In this case, it will just save the file with comma separated values. Okay. Okay, so let's move on to the bonus task. We have two bonus tasks to do today. The first is I will request you to visit this gist repository of mine on the class GitHub account, and there is a file climate.csv, and this file contains around 10,000 climate measurements. The temperature in the first column, the rainfall in the second column, and the humidity in the third column. So download the file and then read its data into a NumPy array. You can download the file otherwise as well, but let us download it from within Python. If you want to download it from Python, we have done this before as well in our file handling module. Let me just brush up. You can use the URL lib package. This URL lib package it has a method URL retrieve that is used to retrieve data from some URL and save it on your local disk. And at times in your system, if it generates a error, URL error, certificate verification error, you just run this cell, set the create default HTTPS context attribute of the SSL to create unverified context. You will not get the error. Okay, so what you need to do is you need to find out this URL from gist.github.com/rfpucat. So after you have got the URL, you just pass that URL to URL retrieve, and you pass the name of the file in which you want to download and save. So this has successfully downloaded and saved it. Let me show you using the cat command of the operating system. So this is the file which has been read. Oops. Temperature, rainfall and humidity. 3 comma separated values, and they are, I think, around 10,000. So let's use generate from txt to read this data. Remember, this data is comma separated, so I have mentioned the delimiter, and since we have a header and we want to skip that, so I have used the skip header is equal to 1 argument to this generate from txt. So now we have climate underscore data. This is the NumPy array, the 2D NumPy array containing this data. You can observe the first row is 25, 76 and 99, and over here the first row is 25, 76 and 99. So great. So we have successfully downloaded this file, saved it on disk, and now we have read it inside a NumPy array. Okay, so you can of course slice the data of the first column, that is the temperature column. You can slice the rainfall column and you can slice the humidity column as well. We have seen this in our previous session, how we can slice the data from a 2D array using a comma in between and a slice operator on the left and a slice operator on the right. And on the right, I have just mentioned the column number or column index. Great. So now if we have these columns, we can easily compute the mean of the temperature, mean of the rainfall, and mean of the humidity. Great. Okay. Uh, let's now create a fourth column inside our data. Our data right now has three columns. Let me create a fourth column. And what I want to do with that fourth column is, let's suppose that I assume that the temperature column has a weight of 0.3, the rainfall column has a weight of 0.2, and humidity column has a weight of 0.5. I just multiply the matrix with this weight matrix to get the new column. So this is the new column. So new column has been obtained by the multiplication of this climate data matrix 10,000 by 3 and this array matrix, this weights matrix. So we got another column and the shape of this is 1000 elements. Okay, we need to convert it to a matrix having 10,000 rows and one column. So I am using the reshape method on this new call, and we have got a matrix 10,000 by 1, so that we can now concatenate this matrix with the climate data matrix. We have seen concatenate in our previous session. So concatenate can concatenate on the axis 0 as well as axis 1 in case of a 2D array. And naturally, since we are concatenating the column, so we will pass axis is equal to 1 to the concatenate method. So this is the concatenate method. I am passing it a tuple containing the two matrices or the two NumPy arrays, and the axis is 1. And I will get the resulting matrix, which will be having 10,000 rows and 4 columns. So let's check out the shape of this as well. Great. So we have the temperature, the rainfall, the humidity, and this is the computational column that we have just generated and placed inside this array. Now the final task is that I want to save this new array with the results inside a file. Let's suppose the file name is climate_result.csv, and what I'm going to do is I'm going to have this file. Let me change this yields apple to, let's suppose, call 4 for simplicity. So let me run it. I have used the save txt method, which we have already seen above. Let me use cat to view it, and here is the result: temperature, rainfall, humidity, and this is the call for. Okay, so I think that is enough for the bonus 1. Let's talk about the bonus 2. My dear students, we have also done a bit of image processing in our file handling session. Let me quickly brush up your memory. So first of all, we need to import the image module of Python imaging library, PIL. You can use Pillow as well, which is a fork of PIL, and add some user-friendly features. We are going to use the open method of the image module to get the file handle of this image file, and the file handle is now there in RGB_image because I am reading a JPEG file. This is a color image. Okay, let's check out the mode. Well, this mode attribute tells us that it is a RGB or a true color image, and this size attribute, this tells us the size of this image. It is a three channel image of size 720 rows and 479 columns. Okay, so this is the color image. Let us use the convert method to convert this image to a grayscale image. This transformation used by this convert method is shown in this formula over here, which multiplies the red, green, and blue pixel intensities with these values mentioned over here. Okay, and this will give you a single value that will be placed over there. So after that we have a grayscale image, and the mode of this image is of course L, and the size is of course 720 by 479, but this time it is a single channel image having grayscale intensities. Okay, so let's view the color image now. Let's just view it. Well, yes, this was the memorable event, a sports car at PUCIT. Let's see the grayscale as well, which we have just generated. This is the grayscale image. Let us finally convert these images to NumPy array. So this is the RGB image. I am converting it to a NumPy array named RGB underscore image underscore array. You can name it whatever suits you. Let me check out the shape. So this shape tells you that there are 3 channels of this RGB image, each channel having 479 rows and 720 columns. And let me see the contents of this array. So these are the contents of this color image inside the NumPy 3D array. Let's do the same for the grayscale as well. Let me convert the grayscale image to a NumPy array, and let me check out the shape, and let's check out the contents of the array as well. Well, note that it is simply a 2D array now. A 2D array of size 479 rows and 720 columns, with the pixel intensities ranging from 0, which is black, to 255, representing pure white. My dear students, if you have interest in the domain of image processing, please spend some time and do a scuba diving in the domain of image processing and computer vision. Okay. So my dear students, that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists, and inshallah in the next session we will start with the pandas library. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning, and Allah Hafiz.